Yeah, today we'll discuss about the test bench design and test bench for multiplexer. Okay, multiplexer design and test bench for multiplexer. Okay, let us take two cross one marks. Okay, if you see the first, we will see the two cross one marks. Okay, so two cross one marks. So if you see the two cross one marks, first I will writing using if else statement. Okay, if else statement. Module module underscore 2 cross 1 mux. Okay, input I need to declare yes, and input yes,
A
and
comma B.
next I need to declare input 1 down to 0. Can I declare inp? Can I declare this is inp means how many inputs are there for 2 cross 1 mux?
Put 0, input 1.
I0 and I1, no? So that I am declaring with this is 0 at 1, I0 and I1, INP. Okay,
Put
output
Y.
reg y, output reg y. Okay, reg y, and always at the
Date.
rate I am giving star implication operator, begin. Okay, if s equal to s equal to
1.
1. Okay, s equal to 1, y equal to if it is if s equal to, let us take s equal to 0, y equal to what?
NP 0.
Inp 0. Okay, else y equal to
Else Y equal to INP 1.
inp 1, inp 1, and
End module.
end module. Yeah, end module. Okay, so here at a time any one of the input is connected to the output, that means depending on the selection line. So when selection line equal to 0, I0 is connected. When selection line equal to 1, I1 is connected. Okay, uh, so uh, here suppose if you are writing the any code. Okay, if you are writing any code, we need to write so if it is data flow modeling, we need to write assign block. Okay, we need to use assign block, and next we need to use always block, and initial block. Okay, initial block. So this assign block we are using in the continuous assignment statement, and this we are using in the behavioral modeling. These we call as procedural block.
Processing
Okay,
state.
procedural blocks we call it procedural blocks. So which one will be synthesizable?
Uh, always block will be
Always
synthesizable, sir.
synthesizable. Assign block is also
Understand block.
synthesizable. So this is non-synthesizable. We are going to use in the test bench.
Testbench.
Okay, so this is 2 cross 1 marks, and suppose if I want to write with what we call if you want to write in the by using if else statement. Okay, how to write by using if else statement for 2 cross 1 marks by using if else statement. So 2 cross 1 marks using if else statement is over. Next I need to write case statement.
Case statement. Yeah.
Okay, case statement. So if I want to write the case statement module, so how to
Till 2
write
cross 1.
module underscore 2 cross 1 mux, input yes. Okay, and input 1 down to 0, inp, input 1 down to 0 inp, and output. Okay, output it is a behavioral bonding reg y, okay, always at the rate star, begin
Case.
case yes, yeah, case yes. Okay, if it is like one tick binary 0, y equal to what? inp
INP.
0. If it is one tick binary 1, y equal to inp 1,
NP 1.
inp 1. Okay, inp 1. there will be a default state, default case also.
Default case, yeah. Mm.
Default case. So y equal to what? One tick binary x. One tick binary x. End case and end module. End and end module. Is this case statement is fine?
Yes, sir.
Okay. So this is case statement. Okay. Next I am writing the test bench for this 2 cross 1 marks. Okay. So test bench. So how to write the test bench? So
What you will test bench?
test bench for 2 cross 1 marks. So if you write the test bench, first module underscore 2 cross 1
Cross
mux, 2 cross 1 mux, and is there any
AB.
inputs outputs for the test bench?
No, sir.
No. Step 1. Step 1. What is step 1?
Declare variables.
Declare the internal variables. Internal variables. Okay. Declare the internal variables. What are the internal variables? So here
Input
reg
0.
1 down to 0, inp
Put
comma s. Okay. And wire y. Okay.
I.
Wire y. Okay.
Mm.
Wire y. Okay. And next so wire y and
Instantaneous.
step 2. Step 2, instantiate the design. Instantiate the design. Instantiate the design. Okay, how to instantiate? So that is design name. What is my design name? 2 cross
2
1
cross 1 marks.
and design. Let us
AB.
take DUT. Okay, instance name is DUT, and I am using connection by position with order list. INP of 0, comma INP of 1, comma S comma Y. S comma Y. And what is step 3? What is step 3?
Have to initialize.
Yeah, initialize the reg variables. Initialize the
Till begin.
reg variables.
Sir, or else we can also do the connection by name also, right?
Yes, connection by name also we can use. So connection by name means we'll get like dot. So connection by name
Dot
means
reg of
connection by name means whatever the, so that means underscore 2 cross 1 mux dut. So you need to write dot.
dot
So
input
inp of 0. These are the design input, and in bracket you will get test bench.
input, yeah.
INP 0. Okay, like this you need to write. Dot INP 1 and INP 1.
Input 1
Input 1 and comma. Between comma you will get dot S and S,
of
comma
S.
S and dot Y and Y. So like this. This is connection by.
Sir.
Okay. So initialize the reg variables. Initial begin.
Begin.
So by using concatenation operator, inp of 0
Here,
and
comma
inp of
INP
1
1
comma s, that is equal to what? 0 and end.
0.
Okay. Step 4.
Have to drive the inputs to the design.
Yeah. Step 4, you need to drive the inputs for the design. Okay. So driving the inputs to the design. Inputs to the design. Okay. How to drive? Like initial. We start with initial begin. I am giving s equal
0.
to 0. S equal to 0. I am giving INP of 0, that is equal to 1,
Y.
and INP of 1, that is equal to 0. Okay. After 10 time units, let us take after 10 time units, I am giving S equal to 1. Here S equal to 0 means which one is connected to the output?
P is connected.
INP 0 is connected. Yeah. And next INP of 0 equal to 0 and INP 1 equal to 1 end and end module. Like this you need to write the test bench. Is it fine? Hello.
Yes, sir. Understood. Yeah.
Understood. Okay. Just I'm opening this Vivado. One second. Mux, no? Just go. Multiplexer. This is 2 cross 1 mux. Whatever I told you, 2 cross 1 mux. Like means ternary operator also we can do. Okay. Ternary operator. This is ternary operator. DUT 2 cross 1 mux. 2 cross 1 mux and test bench. This is the test bench. Okay. So here what I am doing. So here module mux underscore 2 cross 1. So reg a comma b comma s1 and so wire y and a dollar monitor I am giving. Okay, initial begin dollar monitor a equal to percentage b s1 and dollar monitor means whatever the last updated values are there.
Input changes. Yeah.
That will be executed. This is data flow modeling only. I want to show you behavioral modeling now. One second. Yeah, you see here. 2 cross 1 mux by using case statement. Okay.
Yes, sir.
2 cross 1 mux using if else statement. Whatever we have seen. If select equal to 0, y equal to a. If select equal to or else y equal to b. Okay. End
B.
line end module. Okay. And coming to the test bench. So I wrote the test benches also. Here 2 cross 1 TB, 2 cross 1 mux. If test bench will be same only, just what will be changed that this design name will change. Okay. So module TB 2 cross 1 if so you need to declare A B a selection and wire y mux 2 cross 1 underscore if UUT. This is a correction by name. Okay. Correction by name and integer I initial begin, dollar display select A, B, Y, dollar display this one. Suppose how many inputs are there?
Two inputs.
Three inputs, no?
Three inputs.
Three inputs. So I, by using for loop, I can check all the possible combination. First, what I am doing,
Mm.
I'm declaring the integer data type, integer I,
Mm.
initial begin. For I equal to 0, I less than 8, I equal to I plus 1. Okay, and
Mm.
after that, by using concatenation operator, select comma a comma b comma a comma b equal to I, and I need to wait for 10 minutes. After
10
that,
seconds.
I need to display and end simulation. Okay, dollar finish is nothing but end the simulation. Is it fine? This text bench is fine.
Mm.
Okay.
Yes, sir.
Okay. Right click, set a stop module. Just so whatever you are seeing, that you need to test as set a stop module. Run simulation, run behavioral simulation. So you can see in the TCL console also. See here, when select equal to like 0, what values you will get at output?
The A values will
A
be
values
get.
you will get. When select line equal to 1, B values you will get.
The B values will be.
B values you will get. And you can see in the simulation also. So just fit to page. So here initially when A equal to selection equal to 0. Selection equal to 0, A value is 0, Y is 0. A value is 0, Y is 0. A is 1, Y is 1. And A is 1, Y is 1 you are getting. Again selection becomes 1. So B value will
Mm.
get. B is 0, Y is 1, 0. B is 1, Y is 1. B is 0, Y is 0. And B is 1, Y is 1. So like this you need to see. So integer means this is a packed data type. No, this is sorry. This is packed. Packed means what? 31 bit, 32. The default size is what? 32 bit now.
31, 32 bit.
32
Huh.
bit. 32 bit. That's why it is represented like this. These are 32 bits.
Okay, sir.
Okay. This is 2 cross and max. Case is okay, no? Case also we
Yes,
can
sir.
check.
Yes, yes.
Okay. Next, suppose if it is 4 cross 1 if else statement, 4 cross 1 mux is there. Okay.
Mm.
So hope you can see, you can understand this. So you need to
Yes.
declare 3 down to 0 D and 1 down to 0 selection and output with reg data type always at the reg star begin. If select equal to 2 tick binary 0 0, y equal to d of 0, else if selection equal to 2 tick binary 0 1, y equal to 1, else if selection equal to 2 tick binary 1 0, y equal to 2, else
Equal
y
to
equal
D of 2.
y of 3.
Hmm.
Okay. And test bench also. Okay. Test bench 4 cross 1 TB if else statement. Okay. This is if else statement. Same thing. You need to declare dn selection with reg data type and y with y data type, and next you need to instantiate and you are declaring the integer I, and after that how many inputs are there total?
Total 4 inputs, like 5.
4
Sorry,
plus
4, 6.
4 4 plus
6, 2.
6, yeah, 6. So you need to check how many combinations. 2 power 6, 64 combinations you need to check.
2, 4, 6, 64.
64 combination. By using for loop you can see the 64 combinations. So this one set as stop module. Set as stop module and run simulation, run behavioral simulation. So if you see in the TCL console, see here these many conditions.
Yes,
First
sir.
0 0. 0 0 means which one is connected?
First 2.
First one. 0 1.
D1. D1.
Next 0 1 means next D1. Yeah. 1
1,
0
0, D2. Yeah.
D2. Yeah. 1 1 D3. Like this you can see in
D-
the waveform also. Okay. Hit to page like this. These many combinations you will get. Is it fine? Mux you can do, no?
Yes, sir. Is it? Yes, sir. Max understood.
Understood. Okay. Comparator you see. Comparator, this is 4-bit comparator. Okay. Comparator we already seen, no? Module comparator.
Yes, sir.
So input 3 down to 0 A and input 3 down to 0 B. How many outputs will be there?
Output should will be uh, three outputs, sir.
Three outputs. Output reg equal, output reg greater,
Which,
output reg lesser. Okay. Always at the rate star begin equal to A logical equal to B. Greater is A relational operator
greater
greater than
than
B and A less than B. Okay. This is my code. And coming to the test bench. Where is my test bench? PB 4-bit comparator. Comparator, can you try this one?
yes, sir. I'll try, sir.
Okay, you can try. Okay, and one more is priority multiplexer is there. Okay, priority mux. One second. Priority mux, I already told, no, like priority mux, all conventional behavioral modeling. This is behavioral modeling. Here, priority mux I told you during behavioral modeling. Have you remembered? So priority mux, here what you are doing, module priority encoder 422. So in the digital we already discussed now why you are going for priority mux. There are some ambiguities in the encoder. Okay, priority encoder. Okay, what are those ambiguities? Like all the inputs are 0, it will not produce any output,
Output, yes,
and
sir.
2 or more inputs are 1 means it will not give proper output. Okay, so we need
Proper
to
out.
give proper priority level. Priority means y3 is having the highest priority, next y2 is having next priority, y0 is having the lowest priority. That we have seen, no?
Yes, sir.
Okay, so this is the code, module priority encoder 422. So input 3 down to 0, input 4 bit, and output reg 1 down to 0 out. One more output will be there, no? Valid. Valid, it indicates, it's a check that all the inputs are there or not. That means at a time any one of the input will be one, no. So it is checking for the valid output, valid input. Okay,
Valid input. Okay.
always at the star. And valid equal to, how it is checking, can you say this operator?
Foreign, if any input is one, okay.
Reduction operator, reduction or
Okay, reduction operator.
unary operator we already discussed in the operators, no?
Yes, sir, sir.
Reduction operator, it check for any input is 1. Okay, so that means suppose 1010 is there, it will do OR operation within the bits itself. Have you remember
Within.
that reduction operator, reduction
Yes, sir.
and
Yes, sir. Yes, sir.
reduction and reduction or reduction not,
Yes, sir. Yes, sir.
and we already discussed.
The
And
beginning of Verilog.
yeah, operators we discussed. KZ, okay, KZ in. So KZ, what KZ will do? It allows the don't care bits also. Okay, it allows the don't care bits also. So if to 40 binary 1, question mark is nothing but don't care. This is don't care. Okay, we already drawn the one truth table, no, from bottom
Yes,
we
sir. Yes,
came.
sir.
So 1 don't care, don't care, don't care, which is highest priority, out equal to 2 tick binary 1 1. If it is 4
One.
tick 0 1, don't care, out equal to 2 tick binary 1 0. That is 4 tick binary. After completing that, that becomes 0 0 0 1, don't care. Then next priority is 1. Okay, out equal to 2 tick binary 0 1, and 4 tick binary 0 0 0 1. Then last priority is 0. Okay, what is the default case? Out equal to 2 tick binary XX. End case. For the case statement there will be a default statement, no? Okay, end case, end and end module. Is this code is fine?
Yes, sir. Understood.
Understood. Okay, coming to the test bench. Okay, one second, I will tell you. Test bench. This is all complete. Yeah. So if you see, this is my test bench. Okay. So module TB priority encoder 422. So we need to declare the declare the internal variables. Reg 3 down to 0 in, wire 1 down to 0 out, wire valid. So you need to instantiate the design. Okay. So design name. What is my design name? Priority encoder 422.
Encoder 422.
Whatever the variables outside the bracket are design inputs and outputs, and whatever the variables inside the bracket are test bench
Testbench.
variables. And you need to you are checking for what condition. mm, for let us take here one change is there. You are using Verilog, no? You need to declare integer. Okay, here I am declaring above initial block. I am integer. Integer integer I am declaring. Okay, for I equal to 0, I less than how many possible combinations? 2 power 4, 16
Uh,
possible combinations.
2 power 4, 16.
16 possible combinations. Here I need to make I equal to what? I plus 1. Okay, I plus
1.
plus will not take. Okay, that's why we are giving I equal to I plus 1. In
I
equal to
plus
I.
1.
In equal to I. Okay, in equal to I. And I want to display these values in the TCL console. I am using $display and $finish end and end model. Is this test bench is fine?
Yes, sir. Yes, sir.
Okay,
Understood.
yeah. So just I am checking this. First you add the design source. What is my design source? Create my file. So design source, let us take this priority on priority encoder only. So this is priority encoder. So this one paste, choose the location. Okay. Okay. Here I need to choose the location. One second. Choose the location. Yeah, okay. This is not that much required. Okay. So next OK and finish and OK. Yes. So my priority encoder design file is created. Just go to this and this one. Oh, sorry, this is Testbench. This is my design file. Copy this and paste here. Priority encoder 422. Yeah, already wrote. Okay, already it's there. Priority encoder 422. Okay, so it's already there. Not required. Priority encoder. Second. Okay. Yeah, I will save this. Priority encoder 422. Next, in the simulation sources, I am adding the test bench. So what is my test bench? Priority encoder. This is my test bench. DB underscore priority encoder. Okay. Adding design simulation source, create file, and priority encoder. Okay, finish. My model name is also same. Where it is at TB priority encoder. Okay. This test bench is there. No? Copy and I am pasting. Save this file. Yeah. Now priority encoder is formed. Okay. This one I need to make as top module. Top module and run simulation, run behavioral simulation. If you see in the TCL console, see here, anyway all inputs are 0 means what is the output? XX. Okay, valid equal to what? 0. Okay, again 0 0 0 1, which is having highest priority means out will be equal to 0 0, no? 0 0 0 1. Okay, out will be what? This is D0, D1, D2, D3, or
D3,
Y0, Y1, Y2, Y3. Okay.
Y3.
So so this 0 0 you are getting. Suppose if it is 0 0 1 0, Y1 will be 1. Y1 will be 1 means that binary representation 0 1 you are getting. Have you understood? Suppose if it is
Yes, sir.
0
Yes, sir.
0 1 1, which is having highest priority?
Y1.
Y1. So that binary representation will get. Okay. Here Y2 becomes 1. Y2 becomes 1 means 1 0 will get. Again here
0.
Y0 becomes 1, Y2 becomes 1. Which is having highest priority?
Y2 only.
Y2 only. Here Y2 and Y1. Here also Y2. Here
Y2.
Y2, Y1, Y0. Which is having highest priority?
Y2 only.
Y2 only. Next,
And then
here
Y3 next
Y3.
one.
Next Y3. Here also Y3. So more than one inputs you are getting. So in all these cases, which is having highest priority?
Y3 priority. Yeah.
Priority. Y3. Okay. So that is we can see in the test bench this one also. Okay. You can see like right click binary and out also right click binary. Okay, whatever right click binary, yeah, whatever we have seen that we can see in the simulation. So here y0 is 1 0 0, here y2 is 1 0 1, y1 is 1 0 1, here y2 is
0
1,
1.
y2 is 1 1 0, and y3 is 1. All these
I3 is
cases
1 again.
1 1 1 1
Y
is it satisfying?
Yes, sir.
Okay, yeah, this is priority encoder and this is discarded. Okay. One more thing I will tell you, like why you are having the this what we call default statement. Okay, default statement in the, I told you, no, default statement in the case statement. Okay, we have default statement in the case statement, no? So if default
Because like or else like the processor, like it has to be in the default state, or else it won't, like it doesn't know where to go, right?
no, if a default statement is not there means it will infer as a latch. It will infer as a latch. Okay, so that I will tell you with one example. Okay, example with the default statement. Okay, suppose always at the rate let us take a or b or selection line. Okay, selection line begin I am using case selector. If it is one tick binary 0, out 1 equal to a, and out 2 equal to a, and if it is one tick binary 1, out 1 equal to b. Okay, end case, end and end module. Okay, end module. Suppose if you are not considering this out 2, how the circuit will look like?
Circuit will look like A and B select
Selection and
A and B.
A and B, and here you have only one out 1. Okay, this is out 1. Okay, suppose if you consider out 2, okay, how the circuit will look like? So that means here you are not using out 2, so here how the circuit will look like means here this is A and B and selection. Okay, selection, this is out 1, and one more mux will be created, so this so like so when selection equal to 0, this will be connected, A is connected to out 1, and next this out to is there, no? Out to this will be given as a feedback. This will be given
Okay.
as a feedback, and this selection line is connected to this one. So that means when selection line equal to 0, it will it will infer as a latch.
Patch.
We already seen we designed the D latch using 2x1 mux, no?
Yes,
D
sir.
flip
Yes, sir.
flop using mux, no? Okay. So otherwise B is connected to output. So otherwise B is connected to output. So in order
So
to
default case is yeah.
yeah, so that means here in order to avoid this latch, so we need to use default statement. Okay, so default, we need to use default in the case. Okay, so default, this will avoid the formation of latch.
Yes,
This
sir.
will avoid formation of latch. Formation of latch. Okay, so this is about the test bench for combinational circuits. Remaining combinational circuits you can try, no? Any doubt
Yes,
or
sir. I'll try. Yeah.
okay? So maximum combinational circuits I covered. So remaining you need to do coding part for design as well as test bench. Whatever the combinational circuits are.
Sir, I will try this weekend. Yeah.
Okay. So Friday tomorrow I think you are going to new university. Yeah.
Again, next Monday I'm going to office, sir.
Mm-hmm.
This like I got this student job,
Mm-hmm.
so I don't know like when I'll be back. It's my first day, so